Hello and welcome to my tutorial series. If you're following along in this tutorial series, this is actually the first in a series of a few videos just on nailing some of the basics of coding. Um, these videos will kind of get you prepared for some of the more advanced topics that I'll go into a little bit later. But this is a video and a series of videos to get you just prepared to build high quality production code so that you spend a lot more time building out new features and solving new problems instead of spending a lot of time debugging bugs that you might already have in your code and might be pestering your customers, and so they feel like you need to solve them with high urgency. So I'm going to start from scratch in this whole series, and this is actually going to be a section of videos available for free. So you might be watching this on YouTube or you might be watching on my personal site. But yeah, these are all going to be free. And then I have a section of paid videos that are going to dive into the much more detailed and advanced projects. And that'll be a chance too where you can kind of reach out to me and get critiques on stuff, and ask me kind of questions that you might be having along the way on your journey. As well as get to build some projects with a lot of other people. So I have some pretty big plans for all of this. But yeah, this is just kind of the basic series to kind of get you up and going and get you ready to go. So the first topic that we're going to be covering is just naming variables. So for people that have already experienced a coding language, this might seem really basic, but I think it definitely has to be drilled because a lot of people actually don't have this skill. So a lot of actually proficient coders that get hired into very good companies like Microsoft, they still don't know how to name variables. And so you might be asking, well, why is it that important? Like, isn't it more important to kind of get going, get the code out, get the feature built, and then you kind of, your code won't break, so you never have to deal with it? Well, likelihood is that someone will have to come back after you and look at your code and kind of, assess what you did, how you did it, and then add on some extension onto it, or they might have to rewrite all of it in a different way. And so you always kind of want that person to be able to come into your project and understand easily what you were doing, and not have to kind of go reach out to you to figure out what you were doing. And so a really good way of coding, I like to remind people, is to think like your code's going to be seen 20 years from now. And in 20 years, you're going to be probably long gone, probably a CTO or something. And so that person can't reach out to you anymore. And so you're going to have to, the person that's looking at this code, they might be trying to solve a live site or just an issue that is pressing and needs to be solved really quickly. And so they don't have a lot of time to debug your code and make unit tests for it and like look at all this documentation. Like, they need to just be able to look at your code, add the fix in, and keep moving. And so that's why it's important to drill down into the nitty gritty on very minute stuff like this, so that as you build on top of it, it allows us to move a lot quicker and just build much more reliable software. So like I say, we're just going to kind of dive into naming variables, and we'll even dive into naming functions along with it, and just kind of throw out some examples of some scenarios that you might be coding, and just how you might want to name them. So we'll jump right on into it. So I kind of have let's just say that I have a sample problem set up, and I just kind of want to transform. I want to do some kind of transformation on some set of input, right? So if I just kind of set up the problem, like let's just say that a user they're passing us in some kind of JSON or something, and it's like, maybe it comes like this, and it's this weird string that's comma separated, and it looks like that. And so we just want to kind of transform that eventually into an array. Yeah, that's a lot more easier to work with, right? So we might call the array entry, and it's like equal to a s d f g. And I'm a little bit lax on my notation, but these would all have single quotes or double quotes. wouldn't matter here. And so yeah, we kind of want to output something just like this. So like I say, it seems pretty simple if you ever worked with like split functions and all that, but we're just going to kind of make a function that handles doing that kind of work. So now I code in C sharp. I really highly encourage people to learn C sharp. It's kind of it's like an evolution on top of C++ or and Java. So it kind of mixes a lot of the stuff from both worlds. I won't say the best of both worlds, but it just mixes the two a lot. It's an extremely performant language. A lot of people in the industry use this language, and it's fairly easy to understand if you come from a Java or C++ background. If you have a Python background or a Swift background, you may struggle a little bit because we have types in this language, and there's a lot more decoration on top of functions when we're instantiating them. But I would highly encourage you to just kind of, there's a lot of C++ or C sharp tutorials out there. I would highly encourage you to go look at some of that stuff and then just kind of come back to this, and we'll just kind of dive into more topical issues here. So anyway, so the first thing we're kind of faced with is building some kind of function here. So the first, I'm just going to say like, oh, I know that it's going to return some array. So we can use a list or an array in C sharp. And like I say, just to make life easier, we don't know if it's always going to be letters that the thing returns back. And so we know the return type is going to be a list of strings, right? Pretty simple. And then here we say that, we're kind of doing some operation on this. So let's just say that we just call it operate, right? And we know that we're operating on top of some JSON that gets passed into us. I don't want to kind of get into data types here, but let's just say that the JSON just passed us the string value of that, and we're just gonna transform it. So, because I don't want to start importing a bunch of libraries. So we have some string come in, and we just call it or like string s, right? All right, and then all we're doing here is we're just setting up this function, just getting it building, and then moving on our way. All right, so cool. Off the bat, things actually look pretty good here. Like if we, especially if we had a comment here just explaining, oh, this is what it does, we might think that this is okay, right? We're technically, as a verb, operate, we are technically operating on this string. We're doing some kind of transformation on it. I've seen transformation as well. The highlighting is so weird. Okay. But I've seen transformation used as well. So technically we're totally right here, right? And we understand what we're doing, but let's just say that someone else comes along, right? So Alyssa comes and looks at this piece of code, and she's just looking through this class that's called program, which is probably also a really bad name for it. And she's looking at this piece of code, and she's like, and she doesn't really have this comment, right? So imagine that this comment is gone, right? And she's looking at this code, and it's like, oh, okay, transformation, it takes a string labeled as, okay, and does something to it, right? Maybe, like, let's just say that this is all a black box. Like, it calls into some, say that there's some outbound call, like, maybe, like, do more transforming on top of that string. That handled kind of a lot more of the legwork there. And then we just kind of returned whatever the result was from that, right? So, all this code is going to fail, but, say that we had some kind of function like that did some work, and then it did all this stuff. We might look at this now, if we didn't know what the exact problem was, we have no idea what this piece of code does. Right? And the function name gives us no hints. Our variable names don't give us any hints. And so we're kind of in a rut, and now we have to do some digging into this, and maybe we have to do some code reading now to really understand what's going on. So as an example of what code reading might look like, let's just go ahead and implement this function um, and see where things land there. So like I said, what we have to do is we're coding out this. So all I really wanted to do was return an s dot split on commas, right? So you know, we can assume that this will work. I need to make a new list. So let's assume that all of this is pretty good, right? And this is not always a good assumption. It may not, you know, it could be a malformed string. There could be new lines in the string and all this stuff. So an s.split would not be strong enough. But let's just assume for this example that s.split is strong enough to give us all the details in between different things, right? Like address labels are a great example of a thing that this would just kind of break on. It might not give you data that you would expect. But anyway, so now we've got this code coded up, and like I said, we have this clear example in our head of what this was doing. But now we really don't understand. If we take this code away, we still don't really get an understanding of why we were doing this. What's the use of this function? You know, and you can imagine someone might come along and just say, well, I don't know why we have a function for this. Let me just delete it. All right. Like, and they're just like, I don't know why someone wouldn't just do this code themselves or all this stuff. Whereas there might have been some specialized logic that we had alongside here that was calling, maybe that was called before getting into this function. So, you know, maybe there was like a kind of parse out method, right? That, and all it did was return a list of strings, right? So it's like it was a list of strings, and it was called parse out, and it took in some JSON object. I don't know if it's going to be really easy to pull that, but you know, let's just say that there was some function like this, and you know, it was called before this function even got called, right? So you pull that out, you break it. Maybe this code got misplaced and put in another class somewhere. So anyway, like I said, you're just not getting any context clues on what this code is doing. And let's just say that this was 100 lines of code, right? Say you can't just use split, and the code to figure that out involved regexes and all this stuff. That would be quite the endeavor to read all of that code to understand what this function is doing, and then figure out where you need to change it. And this function might not even be what you want to change. So like, let's just say that we have an issue in our parser, and you know, so like I said, we had this example string, and you know, like, let's just say that all of a sudden I had an entry come in that you know, it has stuff in it, ASDFG, but maybe on H, all of a sudden we're getting this back, and that's not the right answer. You're like, and you're wondering like, okay, what bug is causing that? Well, then I'm gonna have to go look at my parse out function and then go look through my transformation function. And if my transformation function had a very clear name to it, I would instantly know, don't go look there, right? And like I say, this code, I shouldn't have to read this code to figure out what it's doing, right? So all I'm trying to say is just here we can give a little bit more information to the function name to try to explain just what we're trying to do here. So indeed, we are doing a transformation, but that just is too general of a term. Think about adding another qualifier onto it, or think about just adding another now to it. So in our case, you know, like, let's just think about, let's ideate on a few things that we're doing here. So we're kind of doing a split out that comes to mind. we're reformatting something, we're turning this JSON into this kind of format. We're like, what's the purpose of this, maybe, right? What is this going to feed into? So let's just say that this is maybe this is like a pre-production process. So we've just taken in user input and we're just forming it well. So there was a giant function called up here. Maybe it gives you some data object. Data. It's not gonna let me type it, but yeah, it has some data object, and its whole goal is just to format user input. Right, so now right then and there, you can kind of get a good idea of what exactly is going to be happening in this function, right? And so it's like we have this format data object, and I'll just go ahead and instantiate this class. I really don't want that. Class data. But yeah, I'm just going to go ahead and make some of these classes down here. All right, so I can get some of these errors out. And so format user object, what it might do is it might parse out the JSON object, var result, and then we pass those results into transformation, var more results. And the way I'm coding right now is just how a lot of people might code when they're first starting out. Right. So in this example, I gave a really clear name for something. Just to get rid of the last error, new JSON object, and then we're just going to call it format. I need to make a new program. P1 equals new program. And I'm just going to be p1.format user input j or v1. Okay, cool. So yeah, here's a clean example of just like what someone's program might end up looking like. And data. Okay. I am getting an error here because that's not a string. I'm just gonna give it that. All right. So in this case, that's actually my bad. Fix that. Parse out. Now we'll have it. Okay. So here's an example of what some code might look like just in a project that was kind of doing this work, right? And this is actually code that I've seen. So I'm coming in here, and this is the bug that I'm seeing, and I go first. I see this main function, and I pretty much look over this because I'm like, this isn't really executing any code. This must have been some debug code. Shouldn't really be there in a library, but because like let's assume this is a library and this wasn't like the actual console app that this was running from. And so the first thing I do is I just start looking at this list of functions, right? So the first function is a format user input. And I'm like, okay, that sounds pretty good. So you can see how that name gave me a hint at, okay, yeah, this would be an issue that would arise from formatting user input. But formatting user input is a very general space of issues that could be going on with a problem like this. So another issue could have just been that something dropped it, right? So immediately when I look at a problem like this, I just think, a variable overflowed, or a variable didn't get set properly. There was a null exception that got caught incorrectly. So when I look at this format user input, my initial idea might not be, okay, it's a formatting issue. But at least I've kind of queued this in my head and gone like, okay, cool. Formatting could be the issue. I'm going to keep moving and seeing if another function name gave me a hint at what's going on. So now I look at parse out. And I hear parse out, and I'm like, okay, that could be something too, along with it. Sounds like it's a little deeper down the line. And you can see how that name already cued me in. It told me, okay, there's an issue that's a little bit further. This is a little further down the line than a format user input. This is more general than parse out. Because if you're parsing out something, you're probably not then going to go into formatting the user input, because formatting user input really makes me assume that you're at the first layer of an API, right? So this is something that an endpoint might call, whereas parse out might be something that format user input. And another really great cue to give people an idea that this isn't something that an endpoint is calling is to make this function private. And that's a great clue to me that, okay, this is not something that my API is calling directly into. This is something that's deeper down the stack and like is really kind of in the nitty gritty. And when I have that kind of cue, then I know, okay, don't start deep down the stack. Like we want to start as high up as we can and then work down, right? And then we go here to transformation. And now after having titles like format user input, parse out, and then getting to transformation, I have no idea what transformation means. Maybe in this context, I can kind of figure out like, oh, I guess it's, maybe after parse out it transforms it, but I don't know what it's transforming it into. Like, why is it transforming it? I don't really have a clue there. So you can see when we have kind of two, like this is a really great name, this is an okay name, and this is just a really awful name. You can see how all of a sudden our lives are a little bit more complicated, because now I'm faced with the prospect of having to follow a stack trace down all three of these, right? And so why this is important is when you're debugging an issue, you have to kind of set breakpoints somewhere. And so I'll make a whole video on debugging, but with debugging, you don't want to place a breakpoint way up in the stack, because you're going to sit there debugging for hours. You want to try to place that breakpoint somewhere. If you can get a repro or a reproduction of the issue, you want to try to put that breakpoint as close to the issue as possible, so you don't have to travel so much and you can kind of quickly iterate in that spot. So I'm kind of faced with the prospects of, well, I guess I'm going to have to put my breakpoint here. Now, in a simple project like this doesn't seem that bad. But imagine if this function called 10 other functions, right? And each function was itself 10 lines and called multiple other functions. That might be a fairly expensive breakpoint to put there. And like I say, I could still be sitting there for the next hour walking through a stack trace. Whereas let's just say that I know the error is right here in this transformation blob, right? Because let's just say that I had some optimization code put in. So I just said if the length of my string, let's just say that it is less than or equal to let's just say that for some reason the length of my string gets turned into like a byte, right? So s.length, and so I just say that, if the length of that is like ever gets greater than 256, then is it gonna catch it? To integral constant is outside the range of type. Oh wow, it actually caught you. So I mean, you're not gonna always have Visual Studio to catch you on something like this, but let's just kind of keep going with it and see if it lets us build. But let's just say that, okay, if we eventually get a string in that's too big, right? It's byte, and notice that this is the byte. This is the converting of length to a byte. And like if that ever got above 256, then we kind of just bail early, right? We return null. So in this case, I didn't get to 256, but you can imagine that I have 257 characters or something in here, right? And it eventually, and like our string length got to that, and we return null. And maybe for some reason our thinking, there's a lot of things that could go wrong here, right? Imagine that we had built our own string data type, class string type, and it's, you know, it's almost just a wrapper on a string, like inner string. And as a note, if all this stuff is like a little bit too complicated, please like take some tutorials on C#, and then kind of come back to this series if this is moving a little bit too quickly. But yeah, I'm gonna keep going. So let's just say that we have a string, it's a wrapper on like this inner string object, and then for some reason the person defined the length as a byte, right? And they were, you know, they were being clever. They were like, oh, we can kind of save space if we do it this way. Or maybe it was a byte array, and they forgot to go back and implement that. And it's like it only gets initialized with the, you know, a single byte. And, you know, for some, like you can imagine some implementation issues happen with this data type. And we just do string dot, we do string type here. It breaks a lot of code up there, of course, but now it's going to be length. Oops. I don't really have to do that byte conversion anymore. I spelled it wrong. S. Not length. Ooh. Might have to make it public. Should be fine. Let me just make this class public. And I'm doing a no-no by defining all this stuff here, but it's all right. This is all demo code. Okay, cool. So we're just back to getting a warning. So imagine that, cool, we have this kind of object, and we'll just request the inner string dot split, and this is the code that we have, right? And so you know, and in this case, yeah, like this was an optimization maybe that we were doing for some reason. Like we, you know, maybe there was like a business rule that we were just saying that we don't want to accept any input because no user client input should be coming in greater than that size, right? So that all needs to be kind of spelled out somewhere, and it should be easy to go figure out like where this bug is coming from. And in this case, it's really easy to look at the code and like find out where the bug is, right? You can read this, you can read this, and then quickly be like, okay, the code is here. But imagine, once again, this is 300 lines of code. All this stuff is like abstractions on much more complex functions that got called inside of here, and there were bunches of function calls inside of here. So it's not so easy to just read all the code in it. All we could have gone off of is the function name. And we would have needed to know the exact function name to call so that we could pop a breakpoint there and then move into that piece of code and walk through it to better understand it, because at least that's 200 lines of code for this function instead of maybe 1,000 to 2,000 lines of code from a higher up function like this. So you know, kind of, so given all of that, what's something that we can maybe do to kind of give a hint at this not being the right, at this kind of being the function that handles this kind of conversion to another format. So you know, so I think like I brought out at one point just thinking about what the purpose is of all of this. So we are formatting user input. So another idea here is to get even more specific. What are we formatting it for? So maybe this is like maybe this is kind of a list of party participants. So I've kind of given it like that, but you know, the real world list of things is maybe it's like, yeah, it's a grocery list. It's apples, bananas, candy. maybe lettuce and olives, right? So this is what the actual thing is, and we just wanted to kind of split out, and we know that our front end is never going to have commas like in between things, and it's not going to be addresses, so we actually understand the space pretty well. And so we just kind of say that this is the entry list, and we wanted to come pop out a list, a string of all of this stuff. So in this case, what we might come up here and say is we want to kind of we might want to transform this into grocery. So we know we have this JSON object coming in, and we're getting out a list of groceries. So maybe it's kind of an extract grocery items. And you know, keep in mind, like if this were a conventional JSON object, it could be a dictionary of a lot of different stuff. It's just that for us, we only care about the entry key inside of that JSON. And so we extract out, so we only want to extract out all the things at entry, because that's going to be where all of our groceries are, right? And that's going to be the thing that we want to transform into a list. And so we rename this one to extract grocery items, and I'll make this code work. And then we come down here to transformation, and what I said transformation was doing, so we have parse out. And so parse out is actually not a bad name. This is probably not a method that would need to belong in here. This is probably a method that's a helper method that needs to be kind of defined in another class that's maybe a JSON class. But this is probably the thing responsible for giving us the string object piece that we care about, right? So parse out maybe grocery items object, right? So, you know, if we did want to kind of include it still in this section of the code, we would make something like this. And this is just the code. And what I'm going to do here is another handy tip. It's just, you know, just leave a comment, right? Responsible for pulling all grocery related fields from the input JSON. Okay, cool. And so we'll kind of leave it at that. You know, maybe you would fill that in too with some more details. But so yeah, we could say parse out grocery items objects, would do this. And so what that's cluing us into is that, okay, this is probably manipulating the JSON somehow. Once again, we have a nice relationship. This is a very general term, extract grocery items. And this is very nice for someone else that wants to come later. And they're like, hey, I have a JSON object and I need to get the grocery items out. This allows them to kind of quickly do a search throughout our code base and just go like, oh, you know, is there, and this is the just the code search, but this is the file search, but you know, there's a project search as well, which is not coming up. Okay, whatever. But so yeah, it would allow someone to kind of quickly look up grocery and then JSON, and they maybe be able to see a function here that's called extract grocery items instead of something more generic like extract items, right? And maybe it's in the grocery kind of grocery parser class, but if you're searching for this stuff, it's not going to be really relevant. So even when your class name is really good, you might still need to say extract grocery items to kind of give that nice clarity to the search engine or the person searching that, okay, every time I search grocery and JSON object, I am going to find this object here, because you don't want someone to recode all of this for you. So that's another perk of just having really good naming conventions for stuff. So like I said, so we renamed this one. It was already a pretty decent name, but then we renamed it and it's now an extravagantly good name. We also managed to rename our class, which is fantastic. You know, and we have to of course fix our code in a few places. And then we kind of came down here and we renamed this class to an even better name, parse out grocery items objects. um, instantly I read that and I go, oh, I don't necessarily, this doesn't have to be a JSON object. So this could have been this could be an XML file or whatever. But now I kind of have a good idea that this is just responsible for parsing out that stuff out of a file. And so now all we have to do is come down here and we still have this transformation function, which still, it feels like a pretty good name, but it's still just not quite hitting exactly what we need. And so what we can do here, I'll just quickly fix this issue. What we'll do here is we just kind of need to give it a better name. So we are transforming something into another. So we're transforming this comma separated list of groceries into a simple list of groceries. So you have a few options, right? So you can say string to list, right? Very common kind of name there, but we still have the same problem. And it's also very evident, right? It's almost condescending. Like we're taking an input and we're returning a string. It's like, it's very clear. Not to mention, this is not a general purpose string to list function. Like this is doing some very specific stuff with comma separated stuff. So maybe we say it's comma, CSV string to list. But we still have a bad problem there because, like I mentioned earlier, this is not the best way to comma separate parse lists. There's other much more involved ways of parsing commas, because like I say, address labels that have new lines on them and all, they need to be able to parse through your parser. And so all of that stuff's coded in much smarter libraries than what we have right now. So this is still not quite getting it across. And in fact, if we were looking for a fix on this bug, we might look right past this because we're not thinking about parsing code being the thing that's broken. That sounds pretty robust, right? So it probably is going to be the last place that we look. So what's another hint to kind of boost it up to our, maybe the thing that we want to look at, right? And so we might just kind of say that this is, it's kind of doing a little bit of parsing, but and it's doing transforming. And so I'm gonna kind of take a moment to think about what's a good name to kind of put here. Okay, so I'm back. I'm sure that you might have come up with something that's pretty good. So what I came up with is I just want to call this I just want to call this extract all grocery from string. So you might kind of say, well, we kind of have extract grocery items here. And we also might have this extract grocery items object, parse out and extractor interchangeable. So, we're using extract a lot. And so it's kind of unclear, right? But like I say, remember that we have kind of these little indicators here to let us know that, well, these aren't API calls. Right. And another little flag that a lot of people will add in are these things that just kind of let people know, hey, these are private, completely internal calls. They might be very similar to other calls, but they kind of have very specialized purposes. So while they might have similar names, when we look at the code again, and I'll just quickly fix the code for us. Now when I'm looking at this code, I say, okay, I come into this grocery parser class and I see that it has a call that extracts grocery items from a JSON object and returns it to me as a data file. I'm like, okay, great. That's fantastic. I look at this first line. It extracts grocery item objects, and it's like, okay, it pulls it into a result. Not a good name, but we'll come back to it. And then we come into more results, which extracts all grocery items from string and results. And it's like, oh, okay, cool. And this is great. And so this is actually why this is really useful is twofold. So you think about the problem that we're solving here. We might say something intuitively might hit us and go like, well, if I'm not having issues here, yet I'm having issues here, then I'm probably not having issues parsing out this thing from a JSON object, right? Probably just not going to have those issues because, this thing would be failing if it failed to parse objects out of a JSON object. So, and, if I'm looking at the input, then I can maybe look at the input and go like, there's nothing that's really queuing in my head saying that this is a JSON parsing issue. So then now if I look at something called extract all groceries from string, I'm a little more curious going like, yeah, this is a string and there is a parsing process that must be happening on it that's returning a null. And that cues me in and boom, I put my breakpoint on 41 and I debug and I might instantly see the issue, right? So that just kind of gives, that's one example. I know we really went into details on it, but that's kind of all about, that's what this whole tutorial series is. It's just going into the deep details and the deep theory on why we want to kind of follow some of these conventions when we're coding out this stuff, because it can really reduce our time when we're coming after these problems and we're tired and we don't have a lot of clues to go off of. Like, it's just a very generic error. Like I say, you might get this null output and you don't know where this is failing. Like in this case, we had a very simple JSON, but imagine your JSON has hundreds of lines in it, lots of complex arrays, and then it just is spitting out a null. You might not have a lot to go off of, and you don't really want to spend your time debugging just all those lines of code. You probably aren't going to fix the problem. You're probably going to punt the bug. So we want to make it to where we actually feel encouraged to solve the bugs. Also, another little perk I was mentioning earlier, while we have this as a private function, we might look at this and say, this is actually a pretty nice function that other people might want to use. And so that might encourage us to make this a public method so that other classes can just pass in strings. So let's just say that our API right now, it takes JSON, but let's just say that we had a program, a console app that was running, and we typed in a list of groceries in that console app. We want to have the same functionality. Well, we don't have to call this function anymore, and this might get extracted out to some JSON specific class, but then we have this function that's going to work for everything, right? As long as you can give it a string data type, it's going to always extract out groceries. And right now we gave it a list of strings, but and ideally in the future, you would actually give it either a class or a struct called grocery. Oops. So, so this is what you would end up kind of getting. This is probably not going to work. Yeah, that's not going to work, but you get the point. You would, so now you have a very, very generic function that's, publicly accessible, and you might pop that out into another kind of, this gets into proxying and all that stuff, but now you've kind of given people a very clear hint that this is a very useful function, probably a very highly hit function, whereas this is much more manipulating the data to get it into a format that we can use, And then this is just the API endpoint. If we had an Azure function, it probably called right into this class, right? Right into this function. And it's like, that's probably not where we want to immediately start digging, because we might get a bunch of calls. So that kind of covers naming our functions correctly, but we still need to cover a little bit more about some of our variables. So I'm just going to kind of start from the top. I'm not going to cover the main. I always understand, assume that the main is not going to be here. You never want to kind of have your main in the middle of your program somewhere. And I understand your test code looking like this, but you never want to kind of ship production code like this, because if I use V1 way down the line, I'm not going to have any idea what V1 is and what it represents, especially a JSON object. I still wouldn't even understand if it was J1, right? And same with P1. I'm never going to understand what that is. Instead, I want to name it something like, and C# gives you good hints. Grocery parser is a great name here, because now you can see how it starts to form these English sentences. Grocery parser extracts grocery items, right? And it's like, exactly, it's exactly what you might imagine that a grocery parser would do. So when we come down into here, and we look at our parameters that come in, this is actually kind of okay. JSON object is JSON object kind of inherently, especially when you're building, if you're working within an API, it kind of does give the hint that I'm working with some kind of JSON object. Now, I would really advise people to format their JSON objects. So if anything, I would have told you to have, to make a different class that overloads or that subclasses JSON object in some way, or it defines its own schema in some way. So instead of just inheriting from a generic JSON object, because now the assumption right now is that this can handle just any JSON object, you can actually lower your scope and just say, well, I always know that my JSON object should look a certain way before they come into this class. So you might have had some class down here that's like special grocery JSON. And now this becomes more like grocery JSON, right? And just like that, you've given me a hint at what all my code is doing, and you've kind of inside of here, like I say, you assume that there's a schema defined for that JSON, so that it's very clear to someone that clicks on this, they F12 on it, and they can kind of click clearly look through here, and they see like a whole bunch of attributes, and it's like name, right? And we can instantly know that, okay, well, the name was, it had to have some attribute name in that JSON, or, in our case, attribute entry. And we know that it had some attribute called entry in there. So, it allows us to kind of, once again, like, you're kind of giving more and more hints to people as they come along and look at your code, to be able to kind of quickly move through and understand what all is going on, and keep going. You don't want to make these too specific, because then you arbitrarily constrain your code. It might not really be necessary. Like, this might need to be able to just take arbitrary JSON and keep moving, but I like to kind of give people hints when they're moving through code, just to kind of let them be able to move on their way. And you might have converted your JSON directly into a grocery object just using the JSON inbuilt JSON libraries. And so this is kind of a rotor around the world way on it, because indeed, if you had some attribute things set up like that, you would hope that that library would do all this work for you. Though this might have to be called inside of it too during the deserialization process. So anyway, moving away from that, so we move into this code. We have a better parameter name. And I'm actually going to pop it back to just JSON object. But I'm actually going to keep this name because, yeah, it kind of construes that this is a JSON that's just supposed to have grocery items in it. And your results may vary if you pass in just any JSON into it. So then we move into more results, and this is actually a really good point too. It's okay to have bugs in your code every now and then, right? You can't code for every single edge case, and oftentimes it makes your code really, really nasty if you if you are constantly coding outside of your assumptions. So you have to make a set of assumptions in any piece of code that you make. And so here in this, the base assumption that we make is that entry is going to be present probably somewhere. And down here is where we make that base assumption that entry is present. And so we might throw a null exception if entry were not present inside of that JSON object. But that's not the responsibility of here to figure that out. And it's not the responsibility of here to figure that out. It's like, if you want to be nice, you might throw an exception that's really useful or something. You might throw a nice error to the user on the client. That you don't want to be too specific because that can do security vulnerabilities. But yeah, you're not trying to code for every single possibility of JSON in here. Your base assumption is that entry is there, and if entry is not there, you can't do work. And so that's why you might check if JSON object contains the key entry, right? That code might look like that. Might look like more like that, but yeah, that's why you might have code like this present. And I always say exit early, so or maybe throw an exception. So anyway, you have to make some base assumptions as you're writing your code, so don't get caught up too much in that. So now moving into the next line of code, so we are actually kind of looking here. So we have this code called results that's giving us this extracted grocery items objects. And I hate this. This is a super generic name for a variable. So what we want to do is get a little more specific on it. So yes, these are results, but what exactly are they? So what we're getting out of this extract grocery items objects, we're getting some string type out of it. So and we know that it's going to already be input for this next function. Another reason results is a bad name is that results usually means that we've finished. We've ended the work in this function. And so someone might quickly glance at this code and say, all right, that's the results of this function. I can move out. I can assume that's returned, and I'm moving into the next thing. And we don't ever want to give that. We don't ever want to convey that unnecessarily. So what we are getting is some kind of string type object out of here. So maybe that's what we just want to say is these are groceries as strings. And what this does is just quickly tells me, oh, okay, these are groceries as strings, and probably something has to be manipulated on them a bit more, right, to get them out. Another great way of kind of clarifying to someone that these are coming out as strings, because keep in mind, people aren't always looking at your code in IDE. This IDE might not exist in the future. Anyone that doesn't know, that's an integrated dev environment. And yeah, this is Visual Studio for Mac in 2022. This might not be around in 20 years. It could be something completely different interface. And so you need to kind of give them hints that this is the data type that might be returning from it. Don't always use var. So anyway, so we have groceries coming out as string. Now you might be tempted to just call this groceries and call it a day, But the problem is that this also feels just like results. It's like we know that we're extracting grocery items. And so if I see a variable named groceries, then I immediately think the work is done here. I don't, that's the right data type. I can move out of this function, move on, or maybe dig into this function. But what I still need to convey that there's more work to be done. So that's why we say maybe as string, we could say stuff like in process or intermediary data type. We can even directly feed this call into this call just to kind of make sure that there's no confusion, right? I don't like that from a debugging kind of view. It can make your lines really long, and we try to stay within this line for our amount of code. So we go ahead and pull it out as a variable, and we jump it into this next function. So groceries as a string is the best I can think of at this point. It's not always going to be the prettiest thing, but it does the job of telling the person, hey, like this is an intermediary data type. Like I'm just doing a little bit of conversion so I can get ready for the next one. I can use stuff like proxy groceries and object and all this stuff, but that's probably going to confuse someone that's very junior in their career. So I'm just going to kind of give them a hint that this is groceries as a string. You can use this if you want to, right? If you have a different parser that you want to use, just pop this object out and use it. Otherwise, I'm going to keep moving into my next call, which might be which really is just my list of groceries, right? And this is where it becomes totally okay to kind of, relax what you're calling things at this point, because you might say, okay, yes, like this is indeed returning a list of groceries, and like I say, instead of doing a generic data type, I'm actually going to return a list of groceries. All right, cool. So there we go. And just like that, our code just became much more insanely more readable, right? Just jumping into this code, like like I say, assume that we don't have this main function. There we go. Assume we don't have that main function. I jump into this class. It's called grocery parser. And I look at here, and it has an extract grocery items function, and it takes a JSON object. So I know that I'm feeding in some JSON somehow, and then I'm going to get this list of grocery items. Well, I don't necessarily know what that API, what that struct looks like, but I can probably quickly, F12 into it and kind of see what all's going on there. It would actually look very similar to this. So pop this out. So I kind of quickly at a glance, right, without even looking at my code, I'm like, I know that if I feed this thing a JSON, I'm going to get a list of grocery items out. Now, there's a trick, right? This thing requires that it has an entry key. And so you might want to convey that somewhere, like in the comment up here, how to use this function. You don't want them to have to dig into the code to find this one line that says that it has to have a key. So, in these cases, that's why I say you want, either you want to make sure that the thing getting passed in is constrained in somehow. So, sometimes you use parameters to constrain, right? You can even say something like grocery key, right? String grocery key, and just by default you set that equal to entry, and then we consume that later. And now we have the ultimate and clarity function that just tells us, hey, if you feed us in this JSON object, and assume we have a comment up here explaining all this. If you feed us in this JSON object and you tell us the key where the groceries are listed, Now the function's that much more extensible, because now we can take any JSON object that has a grocery key in it and parse it out right here for us. So it's now we just, and with very little work, we've made it super, super extensible. So, and then yeah, what this does all this hard work underneath it and gives you a list of grocery items, which is like, oh sweet, like that seems like a super useful function. And so now we kind of go down to the next function and we say, oh, it's a private type, so I can't really call into this thing. So I'm assuming it's doing some internal kind of gear work, and it's extracting grocery items objects. It's like, okay, it's extracting grocery item objects and it takes a JSON object. So I know that it's yielding some kind of intermediary data type out of here. And maybe, yeah, there might be some manipulation I could do on this name, because it's like, okay, I'm thinking that maybe it is giving me all of the grocery items from this file. So I could maybe manipulate this function name a little bit more to kind of make it tell me exactly what it's doing. But overall, I do have a good hint that it's taking this JSON object and it's returning a string type. And that might be weird to me, because it's like, well, I'm only used to this being a string of something. I'm not, but this API up here told me that it's giving a list of grocery items. So I know that there's probably something deeper down that's doing all the work to give me those groceries out of this string, or out of my JSON. So I move on down, and keep in mind that we've only looked at the names of everything. So I move down here and I see that, oh, this gives me a list of grocery items. It extracts all groceries from string, and it takes a string type S. This is one of the few times I will really let you use S, but I really would prefer us to use like something like, a comma separated groceries, right? Once again, gives us a beautiful hint that the proper way to use this is a comma separated string. Now, we might understand that there's no way for us to control that, right? Like, we chose a string data type, and someone can pass in whatever they want, and we're not necessarily going to make a data type just for the representation of groceries as a string. We choose to be loosey goosey here because we're moving a little quickly, and we're not going to have a very specific data type just for groceries that have commas in between them, right? So we just kind of say, all right, I accept it. This is these are comma separated groceries, and we just kind of, it's a goodwill, for someone calling this function, that we just say, please hand us a comma separated list of groceries. Otherwise, you can't really expect this code to work. And like I say, this is a place where you could get lost in the weeds for building cases around your edge cases. And it's just that you can't, at the end of the day, you have to build for your main use case. And if it happens to work for some of your crazy edge cases, then that's great. But you should prioritize formatting your data before it gets to this point, so that it just works for your simple code cases that are easy to understand, right? And so, like I said, here's that. All that is to say that at the end of it all, this is what we end up with. And it's like, okay, it's very understandable. If we compress all these down, we can quickly look at this. We don't have to look at any of the code. We can quickly jump in and just understand exactly what everything is doing and be on our way, right? So like I said, we faced this bug that we were faced with at the very beginning. And, we have 3 things that we can look at. And I think that pretty immediately we might jump to this third function and just start to kind of look at stuff. And if that's not your first intuition, that's totally fine, right? Naming conventions will change for different people on different teams. And it's just more important that your functions always kind of tell some story, right? And that it tell the accurate story of what's going on inside of it. your function names aren't always going to be pretty. Like I say, all of these having extract in the front is not ideal. It's a little bit generic. Extract means a lot, but the fact that we keep going into it, we say this is extracting grocery items, and we give hints over here, and this is extracting grocery item objects, and it's like, okay, that's, and like I say, I would probably keep talking, right, as C comma separated string. Let's just say CSS was commonly understood as comma separated string. Or what does say CSV? And then we come here and we say extract all grocery items from, and maybe here I might similarly say CSV, right? So now we have beautifully worded functions that and they're very powerfully worded, but it's actually the truth, right? Like someone might not think that they built a parser that parses comma separated value strings, but they actually ended up building that. And so you want to communicate that to your other devs on your project that, hey, I actually built this parser that parses comma separated values, and we can use that for a lot of other stuff besides just our API, right? So when I'm building a unit test for this code, I'm not setting up necessarily a server to call into the API endpoint, or I'm not manipulating JSON objects. I can just pass this a comma separated string and I'm good to go, right? And as a dev, it's invaluable to be able to get all that from the first glance at reading a function, right? Because that allows you to move on a lot quicker to much harder problems that I need to solve. So, and yeah, at the end of the day, we did multiple iterations on that, right? And we might go off to PR and get even more feedback. But at the end of the day, we ended up making a beautifully understood piece of code. And I think that's what matters, right? When we come back to this in a couple of weeks, right, we can quickly look at this code, understand what it was trying to do, and then move through it to try to add more features to it, change things in it, right? If we want to go get rid of the bug, it's easy to jump right into that code and go do that. So that's all that I'm going to talk about on that for today. I'm sorry that went a little bit long-winded, but it's just a lot. It's a lot of nuance to go into on it. I'll try to kind of make them a little more bite-sized. But yeah, this was just kind of a seminar on naming conventions, and we'll encounter this a lot as we kind of make more projects throughout the entire tutorial series. But I wanted to kind of put this out there very early on in the series because this just makes your life easier as you're working with people. It's one of the first things I see wrong with people when they join a company. It's just they have a hard time naming things the right thing. And so this is just kind of a introduction to what that all really looks like and how it should just some practical advice on how you might name it. It's not very academic. I don't find that I learn with that style. So, if you do think that you need some resources like that, please let me know. I can always try to write this stuff down and try to get into a more solidified format. But, if you do like this, please let me know as well. So that is all for today. I hope you'll join me next time for some other topics we'll be discussing.